And welcome to our new webcast about industrial LEDs for multispectral and SWIR applications. So today with our partner Genesi Elettronica Lux, we are going to discuss about applications and basics of this technology, etc. So my name is Louis Granic. I am a sales from Laser 2000 in France, and we are going to discuss about this topic together today. So as usual, we will do a quick briefing about what is Laser 2000, and then we are going to discuss about the topic that interests us today, so industrial LEDs for multispectral and SWIR applications. Okay, let's go. So at the end there will be a Q&A session where you could where your question will be answered. So please use the chat panel to ask your questions, and we will try to answer everyone's question at the end of the presentation. So Laser 2000 is a company specialized in distribution of photonic solutions. We are everywhere in Europe. Located in mainly in Germany and France, but we also have offices in Spain and in the Nordics, with also partners in UK and in the Netherlands. So we are specialized in bringing solutions to our partners to mainly in the photonics field, of course, but also we try to help them to design and conceive new solutions, and not only solutions we have in our portfolio. So let's go for this new webcast, and Giuliano, this is your turn. Please enjoy.
Okay, thank you, Luis. Okay, thank you, Luis. And my name is Calzolari Giuliano. I'm in charge of Genesi Elettronica as a senior hardware developer. I've been developing for Genesi Elettronica since 2015. And then I am really enthusiastic in LED lighting. So that is the that is the topic of this presentation. Here is some points that we are discussing in our presentation. Few words about my company, and an overview of multispectral and SWIR systems and LEDs illuminator. Some applications directly from our customer. Some advantages and disadvantages of both old solution and new solution presented by us. And above all, about solution, we will show you a couple of products we have developed for SWIR and multispectral applications. Some application examples at the end, and at the end, contacts. Genesi Elettronica has been in the market since 1991, and since there we have developed a lot of industrial grade boards. Fields covered are automation, human-machine interfaces, radio frequencies applications such as RFID technologies, and then also medical applications and vending solutions, and at least, but not, last but not least, lighting. That is the topic of this presentation. Above all, Genesi Lux, you can see, is the division of Genesi Electronics specialized in lighting. What is the state of the art of multispectral and SWIR application? Nowadays, we have seen that multispectral application used as a light illuminator, a halogen lamp with a spectrum very like to the solar spectrum. And then the source illuminates the target. The target reflects part of the information, and then there is a filtering system. You can see a rotating system that selects the proper wavelengths, and it has been acquired by the camera, as in this application. The target of this application is to highlight properties of some parts of interest. For example, the level of humidity in salt, sugar, or rice, for example, or to discriminate different kind of plastics and or properties typical of some parts. Other application of SWIR and in general multispectral is, for example, optical sorting. As you can see in the picture, you can see parts as in the picture. You can see parts not discriminated by the color. The color is attributed by the system once they have been illuminated with the proper wavelength. Another very important topic nowadays is the plastic waste recycling. Discriminating different kind of plastics using optical systems is now possible if you use multispectral or SWIR applications. Other topics are, for example, pharmaceutical, to discriminate different kinds of pills, or other jobs are semiconductors as photovoltaic, that are very important nowadays. Chemical analyzing or food safety analyzing, for example, to see rotten parts in foods. Halogens is a good light source, but involves takes a lot of problems, because if you see the spectrum involved in produced with halogens is reduced in SWIR area. So the first disadvantage of halogens is that the amount of light emitted for SWIR application is very poor, and by the point of energy consumption is not a good solution, because you lose a lot of energy in parts that are not of interest of SWIR applications. Then halogen light needs a lot of heat to work properly. It reduces its lifetime, more or less 1000 hours. And high temperatures also produces overheating of the part and instability during the time. Applying mechanical filters before acquiring images needs a lot of proper properly tuned filters, and replacing them during working makes a system very slow. So limited number of filters and mechanical problems are involved, especially when the environments are dusty or there is a lot of water or vibration. Now that SWIR application becomes more affordable prices, you can obtain better performances using LED application. Why LED application? LED application permits you to concentrate the energy you need to illuminate in a specific wavelength, so that you can improve in performance and to save energy of the system. You don't need to move mechanical parts, so that you may acquire, for example, more pictures with the different wavelengths changed on the fly when you acquire the target. You may have, for example, you may change the wavelength on the fly and acquire on the same target different pictures, and decide at the end what is the best one, or to decide for 2 or more different kind of defects. It is possible with the LEDs because you can change wavelength in high speed. You don't have the problem of heat because LEDs works at the temperature of 50 degrees or less, depending also if you work in continuous mode or in a non-continuous mode. So you can save energy, and the system is too cold. You don't need specific filters that sometimes it's hard to choose in the market, but you just choose the LED with the proper wavelength directly. So, where the cost must be moderate in acquiring system, the SWIR Vision offers you a lot of solution in terms of cameras and illuminator. And illuminator with LEDs simplify your life. For example, you can see a graph with the proper wavelengths you can obtain with, in this case, it's a mix of SWIR and multispectral illumination, where you have a good component of solar light, then you can see all the wavelengths in ER, and in shortwave IR. As I have told, illuminator temperature is under 16 degrees. I may say also 50 degrees. So the system has a higher life cycle. The stability is better. And then you can change the kind of illuminator and then choose the one that best fits your needs. For example, you can choose circular shape. You may have a spotlight, or may have also a bar light to work compliant with the linear cameras, for example. Here are our solution for SWIR and multispectral applications. We have two kinds of products. They are different one of the other. different but not so different, because the first one, GVXD multispectral LED bar, it's a module with 280 millimeters length that mounts up to 12 wavelengths, and you can select one wavelength at the time, and the selection is made by a serial bus, and you can turn on one wavelength at the time, but you can choose which or a group of them. So you can turn 1, 2, 3, or all of them, and it's up to you. This module can be assembled in lamps to arrive to up to boards, one to the other. It receives the same power supply, and with the same bus you can turn on any single wavelength on each bar or on all the bar together. So the total length of the bar can arrive up to 213 centimeters. This solution is good if, for example, you have to test your system and you don't have a clear idea of which wavelength apply for your solution. So, for example, if you are developing a new machine or a new acquiring system, you may turn on each wavelength singularly and then shot the picture and then evaluate which wavelength are best for your application. You can choose each wavelength and modulate them in amplitude from 0% to 100% in analog way. This lamp can be strobed also, but the strobe impulse can be sent also only by serial bus, serial communication. So this GVXD multispectral LED bar is good for a setup system, or when your machine or your system needs to be changed in different applications. And the power of light is moderate, because the idea for this product is not to focus on power, but to focus on different wavelengths. The second product is a GVXD SWIR bar with the power LEDs. Modules are a little bit shorter. They are 17.5 centimeters. You can assemble the one to the other to obtain up to 3 meters of length lamp. You can manage from 1 to 4 wavelengths, and this product is suitable if you already have a familiar or you already know what wavelength best fits your application, and then you can customize the lamp for your system. You can choose for example, two wavelengths of one kind and two wavelengths of another kind to increase the power light. In this module, it's not possible to modulate in amplitude the light, but you can rely over a very high current on each LED. The first product, you can arrive up to 1 ampere. In this kind, you can arrive up to 2 ampere. Both products are protected against over temperature. the GVXD SWIR is protected, but you can't control the alarm externally. In GVXD multispectral, you can decide to stop, you can monitor the temperature externally and decide in advance if you want to shut down the lamp before its physical limits or not. GVXD multispectral LED bar, 12 wavelengths. We have different kinds of modules with the different wavelengths. Usually, we work with solar wavelengths and SWIR, but UVC also are possible. UVC, you may choose to use UVC and SWIR, or you may work with solar spectral illumination and RGB, for example. As you can see, the module is really compact, and you can evaluate immediately in a lab or in a research and development studio how it works. Here you can see the general purpose GVXD multispectral LED bar. You can see a good amount of solar emissions, and then SWIR also. In this case, all wavelengths are on and are put in the highest power emission. By PC, it's possible to control directly the lamp, because you can select each wavelength you have available and adjust the intensity of the light emission. You can read the temperature, and if you want, you can decide or to shut down the lamp if the temperature is, for your application, too high, or leave that the system decides for you. In any case, the lamp is protected against over temperature. Some application. You may see that in a SWIR system, you can detect defects that normally at solar light are not visible. In SWIR application, you can see defects in skin, as in this example. I think this apple, this peach, has a mushroom problem. And see that also from the shape in a solar visible system, you can see more details in a SWIR. Another property of SWIR is to be absorbed by some parts of some materials and to be reflected by some others. So with this property, you can decide to see if you want to see an object externally, as in this case you can see the envelope, or inspect what is inside, because in this case materials, object put inside the envelope is sensible to SWIR, and then you can see inside the content inside. Another interesting application is that SWIR are really sensible to detect humidity in materials. In this example, you can see salt with the different degrees of humidity that are weakly distinguished in solar illumination, but in SWIR, the darker means that the level of humidity is higher. Okay. Okay, my presentation is ended. Okay, my presentation is ended. Thank you for your attention.
I hope everyone heard that SWIR application for with LEDs, industrial LEDs is very interesting, and there was a lot of applications. That was the very aim of this presentation, and thank you, Giuliano, for presenting it.
You're welcome.
It was very interesting. So now let's go for the Q&A session. Let's start with the first question. So which wavelengths are available for the high power version? I think, Giuliano, this is a question for you. So what wavelengths are available for the high power version between, so yeah, what are the most usable wavelengths for the high power version? Can you tell us more about it?
Usually we have application with 1450 or 1550 nanometers, because these wavelengths are able to penetrate, for example, objects or bottles or envelopes, and inspect what is inside. So, but other wavelengths are also available from UVC up to extreme SWIR. It depends on LEDs, but mostly extreme LEDs, as I told you, but also other wavelengths are possible. There is no limit.
Okay, and what is the to continue with that question? What is the highest power we can reach with the high power version?
A power version, you may work with 2 ampere in LEDs. It means that you can illuminate with a good contrast up to 1 meter of distance between the target and the camera, more or less. It depends how many LEDs you use and the shape of the camera, lens involved, and so on. But it's very powerful. And if you work in strobe application, you may increase a little bit more, but it's levels are very important.
Okay. So next question, what approximately range of wavelengths belong to SWIR? I think we can both answer that question. So normally we have the visible range of wavelength, which goes to 800 nanometers. Then we enter the NIR range of wavelengths until 1100 nanometers, 1200 nanometers, and then we are going to the SWIR version. Yeah, tell me, Giuliano, if I'm wrong, but sometimes the border of NIR and SWIR range of wavelengths is changing. So it's around 1200, right?
Yes, right. Specifically, SWIR can arrive up to 2500 nanometers, but no application for that wavelength. We stop at lower than 2000 nanometer.
For example, the camera we're using with the product we presented to you here, the Acuros camera from SWIR Vision System is going to 2100 nanometers.
Yes.
And the lighting, the illumination module we presented here from Genesi is going to 2000 nanometers.
Yes.
So next question, interesting. Okay, is it possible to trigger the light via hardware trigger like voltage or 4 to 20 milliampere signal? Giuliano?
Industrial, the second one, the power bar, is it possible to trigger with 0.24 volts? And for 20 milliampere is not at the moment, because usually it is used as a strobe mode. So the strobe mode is not manageable with the 420 milliampere. The multispectral has a serial bus. It could be customized to work with the 420 milliamperes, but I don't know how to change the wavelengths. Maybe creating a relation between the current and the wavelength, but it's not for 420 milliampere is not possible, I think. But serial bus for multispectral and 24 volts for power line is possible. Is already possible. You may want to reduce the trigger voltage. You can slow down to 5 or 10 volts, but it's a digital signal, only digital signal, not analog as a 420.
Okay, okay. So maybe we can answer the people that asked this question more precisely in a mail later or else. Okay. Thank you, Giuliano.
Welcome.
So that's a question for me. Does SWIR imaging require special cameras or sensors? Yeah, it does. It does. The CMOS cameras that we are using usually for visible applications is not very useful in the SWIR range of wavelength. So what we do need is specific camera. The camera we are using, as I said before, the Accurus from SWIR system is using quantum dot sensor that's able the camera to acquire between 400 nanometers and 2000 nanometers. But we also have other solutions like in-gas sensors. So yeah, we do need specific sensors, because we around 1000 we reached the end of the sensibility of classic CMOS camera. Another question. So are in-gas camera capable of registering the visible range? Usually they do not. I think I'm pretty sure it does not. So in-gas camera are specified for SWIR and higher application. And okay, do I need special optics to take advantage of this wide spectral range, transmission, image quality? Giuliano, maybe you can answer. Did you use specific optics on the illuminator module to enable the light to go from 400 to 2000?
In our specification is written that we use polycarbonate lenses or covering, but it's not common polycarbonate. We use a specific polycarbonate to be gentle with the SWIR wavelengths. So it is certified, tested, and checked from a selected kind of polycarbonate that is specific for this wavelengths and certified, so it's not common because extreme SWIR needs to be material that crosses SWIR wavelengths has to be gentle with such wavelengths, not common materials, because you risk to lose in performances or to destroy the quality of the images only for a not good material. So specific materials.
Yeah, exactly.
So that specific optics also.
Exactly, Giuliano. That's why we also use for the camera. If you want to, if for example, your application is about visible and SWIR range of wavelength, you will need a specific camera or two cameras if you want a visible one and a SWIR one.
Yes.
And the lenses you will use with those cameras will be specific to one to another camera. So visible objectives, lenses, and SWIR lenses.
Yes.
So yeah, special optics, yeah. Is it possible to easily replace halogen light with LED illuminator to gain more performance and reduce porous consumption? Giuliano, maybe you can answer. I think that's a question for you too.
Yes, it is possible, and care have to be taken about the wavelength that are involved in your application, and select the right product for that fits the best way for your application. And LED for sure gives more performance in in application and to reduce power consumption. Yes, because as I explained in the past, the emission in SWIR area is really reduced, so that a lot of energy in halogen is spent, and in LED, then instead all energy is focused on the wavelength.
So yeah, that's the good point. We can easily replace with this easy to integrate module that we develop together, and the reduction in power consumption will be from another level because we are specified in taking the good wavelength and the good LED to your specific application. So yeah, that's the aim of this module.
Yes.
Okay, another question, maybe the last one. No, I think we have still time. Is it possible to have other forms of light than the LED's bar lights, e.g. spot, ring, background? So I think that's a big yes. That's a question for you, Giuliano, but I can answer if you want.
Yes, is it possible? Because our normal product is a bar, but of course you can rely on a spot, ring, and the background simply to connect the modus properly, or in most cases to redefine the project and optimize everything to the proper shape and to optimize the heating and so on but usually is it possible, and but most of the cases you have to face with a new project, but it's not is it possible? Yes.
Yeah, and we can, and that's something that you are able with it very easily to do, to adapt with the application
Yes.
and the optical way, the optical path, the optical setup,
Yes.
etc. So yeah,
Yes.
that's a big yes for this question. If space is needed, if you have a tiny setup, we can adapt.
Yes.
Okay, so that was the last question. Thank you everyone for watching us and to be there today. Thank you, Giuliano,
You are
for
welcome.
your presentation.
Thank you too.
I hope it was very clear for everyone and everyone got the point and was interested in this topic of SWIR LEDs for SWIR and multispectral applications. I suggest that you reach us directly if you have any more question, any question. And you can also watch this webcast in 1 week on our website, so laser2000.de. And you can also find our other webcasts on this website, on our website. And yeah, we are looking forward to see you and to see you in the next webcast we'll have. Have a good day, everyone, and see you next time. Bye, Giuliano. Bye, everyone.
Bye bye. Thank you.